brought to you by Orbital Assembly Corporation, with your hosts, Dr. Jeff Greenblatt and Eric Ward.
Hello, welcome to Our Future in Space. In this podcast, we explore the technical, economic, social, political, and ethical considerations of moving people into space to live, work, and ultimately to play. Our species is at an inflection point in its evolution where we now have the ability to sustain life off planet in low Earth orbit and soon throughout the solar system. Do we merely survive on this planet or expand outwards into the solar system and thrive?
Orbital Assembly is leading the way in the development of artificial gravity stations so people can live, work, and thrive in space.
OAC's platforms are market category creators. They are backwards compatible with current standards, allowing for you to move from concept to production at the pace of business.
To learn more, visit orbitalassembly.com.
I am your host, Dr. Jeff Greenblatt. I am the Vice President for Science and Research at Orbital Assembly. And I am joined today, as always, by my co-host, Eric Ward, who is the Vice President for Engineering Design at Orbital Assembly. How's it going?
It's going really well. I like that today, Jeff, to live, work, and ultimately play. It's
I like that variation
humanity, the human experience, right? I'm excited about our interview today, too. We have Vincent Pribble as our guest today. He's the co-founder and COO at Micro Meat, who produce white label solutions to enable anyone to sell cultivated meat both on Earth and in space. Previously, Vincent worked with NASA, Blue Origin, and ULA on the SLS, New Glenn, and Delta IV rockets. He has worked on nearly every stage of launch system development, from early system napkin sketches all the way to launching the fastest man-made satellite around the sun. Vincent, welcome to Our Future in Space.
Great to be here.
Yeah, we are so privileged to have you. And, we want to ask you about Micro Meat and its mission first, but I want to make sure to ask about your space experience, which certainly seems to be rich and quite exciting. So please fill us in on that in a few minutes. But why don't you tell us about Micro Meat, why you founded it, and what its mission is?
Sure. So Micro Meat is working on providing cultivation solutions for anyone who's interested in selling cultivated meat. In order for us to see the life-changing and world-changing improvements of cultivated meat, we have to make it easy enough where anyone who wants to can be part of the game. I started Micro Meat with Dr. Ann Sophie, who is our founder and CEO. After looking at the global situation surrounding climate change during COVID, and really starting to see, I think, an inflection point in the number of wildfires, and starting to see the impact of famine across the world. And part of that was why we both kind of got into saying, how can we both participate and help change things? One of the hardest parts about living today is that we're at a time where our species has really advanced very far, but a lot of the methods that we're using still come from hundreds of years ago. And at the scales we're seeing, they're really starting to impact the planet. So doing things and working on sustainable missions and goals to help change that, to help come back from this brink of the global climate crisis to see that we can have hundreds and thousands of more generations is the important part.
Yeah, I completely understand. And it's sorry, Eric, you want to jump in with a question?
I would say that's an excellent mission. I think that's a really interesting point, and this came up in a previous conversation that Jeff and I had about how the world that we're living in, right, even though it's 2022, is still very much founded on these first industrial revolution ways of doing business, of working together, of these kind of technological foundations that, like, okay, we've got computer processors, but that's a good point. Like, we still get our meat from the same type of farming that we did 100 plus years ago. So I think that's a really exciting vision to try to find ways we can modernize this in a healthy way. So I did want to ask, you mentioned cultivated meat, right? And it'd be nice to get a little more detail, like what exactly does that mean, cultivated meat, and how is this going to become so important?
Sure. So cultivated meat is essentially real meat. It's just grown without using animals. So the process is a simple process with many complex steps in between. But essentially how this works is you find an animal or a species that you're looking at cultivating. You find an animal, you provide it a bit of anesthetic, and you perform a biopsy to take a small sample of cells. And that's pretty much it. That's the animal's part. And that small sample will eventually go out to make thousands and thousands of kilograms of meat. Once that biopsy is taken, we perform some steps on it to proliferate the stem cells that are inside of the animal's muscle tissues. Those stem cells eventually hit, kilogram, 1,000 kilograms, whatever your goal is. And then we basically tell those cells, okay, now it's time to change. It's time to become real muscle tissue or real collagen or gristle or whatever that component is, fat. And then we shape it and we provide that structure to have a real cut of meat. It's molecularly identical in every way. The only reason that it's not identical is because the animal does not die.
Well, and that's obviously a really big distinction if you're doing this partly for animal welfare purposes, right?
Oh, yeah.
Yeah.
So
yeah, go ahead.
What about the resource input, right? Like I can imagine some other reasons you might do this. Animal welfare, of course, important, but my understanding is that we spend a lot of resources, energy, land, et cetera, in growing crops to feed our animal produce, right? That it's something, some percentage, I think, in the US, greater vegetable crops go to feeding animals to then eat than the actual humans just consume straight away. And so when you're looking at this cultivated meat, what about the input resource to that, the energy, the food, that this meat needs to grow versus produce the meat?
Sure. So there's a host of benefits from this. When you look at an overall perspective, the typical traditional meat industry produces about 15% of the global greenhouse gas emissions. And cultivating meat has the potential to reduce that by about 91%. But in every single part of that, we start to see advantages. So the feed, the cereal grains, we're looking right now at global production of cereal grains, wheat, oats, barley. Those are all starting to come down. Feed for cattle, feed for chickens, feed for pigs, all of those are related to your traditional cereal grains. So that all can go away and actually move to human consumption by using cultivated meat. Cultivated meat, our inputs are amino acids and sugars and growth factors. And those things, while difficult in their own right to make, are far less on the scale for emissions than, growing oats and stuff like that. In addition, though, go ahead.
And then the animals that then consume that and all of their inefficiencies, right?
Yes. So for growing the cattle, when you think about Amazon deforestation, 91% of deforestation that's happening in the Amazon is happening because of beef production alone. And, if you look at the amount of meat that we're producing globally and the demand and how much that's increasing year over year, what we're seeing is that that's going to basically, you'd have to chop down every single tree on the planet by 2050 to meet that demand. It's increasing so much.
Oh my gosh. Wow.
So You could take all those farms that you're currently using for growing cattle and eliminate them and allow them to be rewild.
This is really transformative, Vincent. I mean, you and I have talked previously, of course, about this, but I mean, when I see the scale that you and other companies like yours, are attempting, you're basically, and please correct me if I'm wrong, you're basically saying that we can, in a few short years, or maybe it'll be a few decades, I don't know, completely replace the conventional livestock system with this cultivated meat system, which takes up far less space, uses far less resources, and doesn't involve live animals anymore.
I think we're looking at a few decades.
Okay. But you're not talking about starting in a decade, right? I mean, you guys are starting like now or
no,
very
this is
soon.
happening. You look at companies like Eat Just and Good Meat, who are actually selling real chicken in stores in Singapore right now. And they are the first market mover that's actually putting stuff forward, but there are so many in the pipeline to follow that, this is not something that's, where we're thinking about 10 years from now or 20. This is happening right now today.
Yeah, no, it's super exciting. So I guess my next question is, well, I mean, why are you going to space to grow food right now, as opposed to just scaling up on the planet? Or maybe you're doing both, but do you want to tell us a little about that angle?
Well, I think one of the most important parts of space is the fact that humans are a part of it. And for so long, we've seen as the 1960s have come and go, and the heyday of these crazy missions coming out, and the world-changing progress that brought with it, kind of went to the wayside for a while. And so we're at this incredible inflection point where we have amazing rockets on the horizon. We have amazing habitats that are coming out. And the only thing that's missing is how do we feed all these people? And relying on traditional rockets to supply all that, which, while it's feasible to some extent, when we start looking long term, we start looking at thousands and hundreds of thousands of people, that simply doesn't scale. And so starting now to address how do we actually feed people is a good starting point.
Okay. Well, and then I have to ask the dumb question, which is, well, why don't we just build farms in space and keep doing that traditional agriculture, but up there? I mean,
you could. That sounds like a huge waste of volume and resources. But in its own right, it's a critical part of the puzzle. So like this image right here is an interesting one. So back in the 1960s and 70s, there was this huge push for how do we, like when we start thinking long term, you're thinking about space architecture right in its right at the very beginning of people thinking, we have Saturn 1, and one of the early papers at that time was how do we make a reusable Saturn 1 or Saturn 5 and all these kind of things. And these were the kind of architectures they were thinking of, having gigantic farms. And I mean, you can even see like a little, multiple tractors in that image. And as you go down, as you move outside of the rings, you can start to see, more and more animals taking shape. And it was just an amazing premise at the time of how do we pull that off?
Well, I'm guessing the reason they drew animals in these rotating space habitats is because we didn't have the cultivated meat technology that we have now, right? So they couldn't conceive of it. Is that fair?
Or they just wanted to launch some cows and pigs.
Yeah.
Just the heck of it. Let's take a short break and then we'll continue with our questions.
Ideas are powerful things. Ideas drive us to broaden our minds and help us seek truth about the universe around us. We are Rogue Space Systems. Ideas above.
So we have a listener question I'll throw in here. We're just talking about, taking this technology into space and cultivating meat off the planet. One of our regular listeners, Aiden, asks, when this is being grown in space, is there the possibility or concern of deep space particles or radiation contaminating these space-grown foods at all?
So that's a good question. I would not be worried about that at all. So from one perspective, from like a biological perspective, this meat is grown in a completely sterile environment. There's no risk of any sort of bacterial, salmonella, E. coli. There's no chance that when you get this on your plate that you're going to have a recall that comes, a few weeks later. That just doesn't happen. From the radiation perspective, the base of the cells, how this process starts is we have just a handful of cells that we end up proliferating. Those systems, those pieces of cells can be put into radiative protective systems and boxes and chambers for those long-term missions so that you don't actually see any sort of cellular degradation over time. So it's not too much of a concern.
I'm bringing up an image here, Vincent, that we were talking about just before the show, that shows the structure of your artificially grown sort of meat at its beginnings. Would you like to explain to viewers what we're seeing here?
Sure. So this is what we call an actin-DAPI image, and this is a fluorescent image when you take a look at scaffolding. And so inside this image, you can see those little tiny blue dots, and those are the nuclei of individual cells. And the red that you're seeing there, those are those cells that they're actually spreading out. They're forming fibers. They're starting to turn into real muscle tissue. This image is taken mid-culture, so you can really get a sense for how these cells are starting to branch and get comfortable in their environment and what they're going to become.
Mm-hmm. Wow, that's so interesting. So at the end of the process, I guess what comes out of your box? Does it look like a steak, or what's the end product?
Yeah. So there's an interesting part here where there's two paths you can take with our end product. So we can either go straight into a ground product, an unstructured product, which essentially says that the same mincemeat that you get at the store, it's basically the exact same format, ready to cook, ready to go.
Hamburger patties out of it, that sort of thing. Yeah.
Grab your hands, shape it together, throw it on a grill, have a good day. On the other side of that, with some other processing that we go through, we can then basically extrude the different pieces, the meat, the fat. We put all those layers together, and that actually then comes out into a real piece of meat that has the correct marbling and shape and structure that you're used to.
Gotcha. Okay. So really there's no limit to how realistic you can make these. There's more processing steps, but it's still feasible because you're growing it in the same way.
Mm-hmm. And what's interesting here too, from the chef side of things, from the food perspective, is you get into this interesting idea of, because you're not bounded by traditional structure, what can you create? So if you're a fan of filet mignon wrapped in bacon or steak and bacon, or if you like chicken fat and ham, I don't know, you can put those different combinations then together in the format that you traditionally like. So
you don't even have to go with something realistic here. You can kind of, design these meats in a bespoke manner and kind of take us even farther down the imagination in a way, right?
Yeah. And so the interesting thing here is this concept that I like to call reusable bones. It's kind of a weird thing, but it's basically this idea that you don't have to be limited by the traditional format anyways. If you want a ribeye steak in the format of a chicken wing, you can do that. You can take those two really different concepts and put that together. You're not actually limited by the animal anymore.
Yeah. Oh, that's really fascinating.
Yeah, this definitely sounds quite, creative, and I think the chefs will have a field day with it. I just have to ask the question. I mean, do you think the customers will go for it, or do they think it's going to be weird to have like a chicken shaped like a steak, or a steak shaped or whatever,
I think there's a lot of customers that are interested. We've done a lot of market research, and we've shown that About 70% of people are interested in customizing the nutrition. So whether that means specifically saying that you have a ribeye steak with exactly, 12% of fat, or you have a piece of fish that has an exact amount, that's on one side of the spectrum. And there's also then other customers inside of that base. There's about 40% that are interested in actually customizing the full experience, taking steak muscle with pork fat and putting that onto a chicken wing or something like that.
So what about the nutritional profiles, right? Like, could we cultivate a filet mignon that has omega-3 fatty acids that are usually found in fish, if my doctor recommends that, or something like that, be able to reduce the fat, change the balance of proteins in different tissues?
Well, what we can do is we can grab a little bit from different things, right? So you might have a ribeye that has maybe a little bit of salmon fat to get those omega-3 acids, right? We can take that. I'm not sure how that would taste, but very feasible.
Let the chefs experiment.
Yeah, for sure. I think there will probably be a lot of experimentation. You mentioned that what you do is you take an initial small sample and essentially propagate that into, eventually kilotons of cultivated meat. But all from that one initial sample, where if I, go to the store, I get meat from multiple different cows, or, whatnot. Is there any concerns or advantages around, essentially having, a single genetic stock, producing, such a, massive amount of meat?
Well, there's two things. So the one cool thing to talk about here is this concept of immortalized cells. Didn't really know about it until I got into the industry, but essentially what happens is that there are stem cells within your body that can last and double essentially forever. And so when we talk about going and taking a sample from a cow, what we're talking about is going and finding a breed that you like, whether or not it's, from a specific region of the planet, getting those cells, immortalizing those cells, and then using that over and over again. So I think you end up actually in this really cool symbiosis with traditional animal husbandry, because you allow those farmers to really focus on improving the breed and really providing those animals with the best quality care that they possibly can. And at the same time, then as those breeds become healthier and more improved, cultivated meat industry gets this great benefit of we now are seeing, an improvement in our products.
Yeah. So, a decade down the road, you might replace your current stock with a brand new version, as these cows have been bred over 10 years to get even more delicious. Then you would get a new sample and start a new line then, and be able to kind of pass on that benefits in breeding to the consumer.
Yeah, and it wouldn't even be, I would love for it to last 10 years. But at some point,
yeah. So you're kind of, always also, in addition to, producing from a specific line, you're also always looking for, new initial samples to kind of cultivate new lines and improve your, product offerings.
Well, and I think one of the coolest parts with this too is, in terms of breeds, we actually really get into these, exotic, non-standard breeds for specific applications. Like what I think is interesting is when you think about animal health, pets, dogs, cats, and also the animals that we see in zoos. What we're able to do with that is actually provide them with the real nutrition that they would get when they were in their wild state. And we can't do that today. You can't just go out and grab some gazelles and say, okay, lion, here you go. That doesn't really work. But we're going to get to a point soon where we'll be able to provide them with an extraordinary level of care.
Wow, that's incredible. Yeah, I hadn't thought of that application, but that's for basically for species preservation, conservation. I guess that's the term that we're talking about here. That could be a huge advantage.
Yeah, yeah. Oh, that's really
Mhm.
fascinating. So what kind of animal products can you grow? I mean, we've mentioned, beef and pork and chicken and, poultry. I think we talked about fish a little bit. What sort of, meats, what's the range here that this
Mhm.
cultivated meat technology could handle?
So for our technology, we're able to produce fish and chicken and mammals and avian. And so basically, if it's something that's in the sea or on land, we're looking at doing it. Stuff like insects,
Range.
not really touching
Mm.
that,
Mhm.
and also not really touching plants. But there really is no limit on the mammal side of things.
Yeah, interesting.
Mhm.
I guess
Yeah,
that
that's
that
incredible.
yeah, that opens the
Go ahead.
opportunity too for different meats of even species that are exotic, right? Not something you traditionally raise lions for food, but since this process of gathering that initial sample is so non harming to the animal, right? It's
Yep.
non-invasive, I guess, in a way. Um,
There's actually a company, Anji Meat, that is
Mhm.
currently working on creating line meat.
Interesting, interesting. I'm
Mhm.
curious enough to try everything once, so I will at least try when things like
It
that come on the market.
I mean, that actually makes me think that it could make it sort of much less socially controversial to try things that would normally be sort of, like nobody's going to go and say, I'm going to go buy a rhinoceros because I want to know how it tastes like because they're endangered, right? That would be a horrible
Yeah.
thing to pursue. But this would actually allow people to ethically do that.
Well, and
I don't know if
also
that's in your
um, when you think about culturally significant dishes, or you think about incredibly harmful dishes, like when we're talking about like shark fin soup is a great example. That's an easy one where we could take those cells out of that shark and then produce that specific type of tissue.
Yeah.
Wow.
Oh, that's really fascinating.
Wow. Yeah, the sky's really, well, not the limit, right? Because we're talking about growing this in orbit as well, but it's a really
Right, right.
wide,
Yeah.
applicability.
Yeah.
Okay, so I guess now is a good time to ask this question. So you spent some time in the space industry prior to starting this venture. You want to tell us a little bit about that experience and how it's kind of, informed your thinking about this company and where it's going?
Sure. So I started my career at United Launch Alliance working as a launch engineer working on the Delta IV rocket. I worked on a lot of really incredible missions, my favorite being Parker Solar Probe. That's currently at least on its third dive around the sun, traveling at like 350,000 miles an hour. I mean, it's just ripping. It's also an incredible mission if you get a chance to research that. They have some amazing data. I worked there. I worked over at Blue Origin as a lead manufacturing engineer on the New Glenn booster assembly. I did that for a few years before going over to NASA to help work on the launch equipment test facility for the SLS rocket.
So
Okay.
how'd you get from there into cultivated meat? It seems like a pretty big leap, but I'm sure you've got some story behind that.
So I, during COVID, decided that after seeing like all the sustainability issues that were going on, I really wanted to try to get into something that was sustainable driven. And I went on to Y Combinator has a co-founder matching platform, and went on there to try to find someone else who was interested in the same thing. And that's how me and Aunt Sophie got in contact.
Oh, I see. Oh, cool. So you hadn't worked together previously, but Y Combinator made a match.
Yep.
Oh, that's
Right.
really neat.
Yeah, it's
Yeah.
a great function for it. Well, so I think I would like to now ask. Well, Eric, did you have another question before we sort
No,
of
I think it's
talk about
time.
our joint? All right.
Yeah.
So our two companies have recently announced something, and I would like to hear from you what that is and why you're excited about it. But actually, I'm going to keep people in suspense for a couple of minutes because we're going to break here and do our weekly T-shirt drawing first. So if you can stand by for a minute, Vincent, I'll bring you back as soon as we're done with that. All right. So, as people know, we're giving away a free piece of merchandise, usually a t-shirt, but sometimes something else, depending on what we've got in the goodie bag, to one listener who has signed up by becoming a YouTube subscriber. And there are possibly some other ways of letting us know you're interested as well. Eric, you did such a great job with the sound effects the last time. Would you mind giving us an artificial roll
Gotcha.
of the dice?
I should have practiced. All right.
Okay. Wow. Well,
It works.
it's different every time. I love it. I love it. Oh, there's a little hiccup there. We have a winner for this week. The name is Anthony DeBond. Anthony DeBond, congratulations. You are the winner of this week's t-shirt drawing contest. So how does Anthony get in touch with us so he can get his t-shirt, Eric?
Yeah, just send us an email, ourfutureinspace@orbitalassembly.com, and give us your mailing coordinates, and we can send you something from the goodie bag. And for everyone else who's watching or listening, becoming a subscriber on YouTube is the best way to get on this list. So if you're listening on your podcast, just go to our YouTube channel. Pretty easy to find. It's the Our Future in Space playlist on the Orbital Assembly channel. And hit the subscribe button, and we'll get you on the list for the next week.
All right. Well, thank you. And congratulations again. All right, Vincent. Well, we've got you back. Would you care to give the audience a little synopsis of what we've just agreed to?
Sure. So Micro Meat is going to produce a system for producing about 1 kilogram of meat on board the Pioneer space station.
Wow. That is so exciting. I'm just going to bring up a couple of articles that just cover that announcement, which was just made earlier this week between our companies. We're obviously super excited about it as well. And yeah, I mean, we believe in having the ability to grow our own food on station in order to feed to the both the crew as well as the guests who are on board. And looking forward, we'd like to be able to bring this really to scale. So the first steps are to get a company such as yourself to be doing the first few steps, and it'll be going forward from there. Yep. Anything else you want to say about the project, or at this point?
Well, I think we are really looking forward to it. I think one of the biggest advantages to projects like this is traditional space architectures are inherently sustainable. So having a partnership like this in place really helps Micro Meat with being able to build out a completely efficient, functional system that, you know, while it's used in space, the benefits it's going to have on Earth are tremendous.
Yeah, that should really be emphasized.
Yeah,
go ahead, Eric, please.
Oh yeah, it's you know, I think it's really exciting. I mean, obviously, you know, here at Our Future in Space, right, we talk a lot about, you know, this sort of long-term, you know, vision of getting humanity off the planet and what that means, and, you know, seeing, you know, steps like this to solve some, you know, some big problems in you know, feeding humanity is really exciting.
Yeah, we also love that by being able to do this at small scale in orbit with all the challenges that are inherent there and getting that to work, that it will help you to be able to scale up to the millions of tons that you eventually want to be able to grow on the planet.
Oh, yeah.
And maybe one day in space as well.
Well, actually, I think that's a great question. Like, you know, we've talked a lot about, you know, particular benefits on the planet, right? You know, all this land that's being used to raise livestock, you know, could be, you know, really condensed into, you know, cultivated meat and you know, the factories and the, you know, associated things. And that frees up a lot of just, you know, surface area. You know, and you know, all the other benefits we talked about as well. But what about space? You know, why is cultivated meat really important for space exploration and you know, space, you know, eventually expansion and settlement into space?
Sure. So the biggest part with trying to go to space is when you look at nutrient consumption of a single human. It's a lot. You know, when you think about Earth and you think about the traditional 2,000 calorie a day guideline that exists out there, we take for granted just how much 2,000 calories a day is. But when you think about that in space, that's a significant quantity of food. That is traditionally sent up to the ISS aboard Dragon, aboard Cygnus, one of those platforms, and it's already pre-grown. But when you start thinking about missions that go out to, even the moon, or looking at Mars, looking at beyond Mars, you cannot take all of that food with you in a reasonable manner, right? You can send up multiple missions, but from a cost-effective position and a time position, it doesn't make sense. So there's two kind of modes of thinking at the moment. There's either send it all up at once, or go and become a vegetarian. And there's a few challenges I see there, which is, first off, there's psychological effects of saying that you're going to suddenly tell every person who wants to go to space, you now have to give up any part of your diet that relates to an animal product. We've already seen that there's massive psychological effects from being aboard, space analog missions, and those aren't even in space. So providing that next generation of explorers that benefit is going to be important. The other thing that's really nice with cultivated meat is the nutrient turnover time. So with plants, they're easy, right? You take a plant, you put it into your dirt, 30 to 90 days later, you have a plant, you have a vegetable that's grown. The challenge with that is the actual quantity of calories getting out of that is really inherently small, versus that same time frame with a cultivated meat system. You're getting a lot more nutrients. You're getting a lot more calories in that same time span. And that's going to last you a lot longer for sustaining your crew.
I see. And I'm assuming that it doesn't take a tremendous amount of space to do this either, right? I mean, it's not many times larger than the plant area that you would need to grow a crop. So it's feasible to do on a space station, yeah?
Yeah. And what's interesting here is that, so meat is mostly water, right? When you think about the human body, it's 75, 80% water. And when we look at meat that way on board space stations and whatnot, that's a lot easier to think about carrying, rather than thinking about, I have to carry all of these different types of food products and all the plastic and all the packaging that goes along with that. You don't need that anymore.
Right.
So
yeah, it's basically green seeds.
Yeah.
Sorry.
Yeah. As we look into deep space, like let's say a Mars mission, right, where we want to set up, a permanently, inhabited outpost, for example, or eventually, having people just live their lives there. There's still a cycle here, right? That needs to happen. Is this a technology that we could send an initial amount of raw materials out, to a deep space mission, and then be able to cycle through that and be able to continuously produce meat? Or is this something that's going to always sort of depend on a raw material supply chain from a place like Earth?
So I think that's where we're getting into a really, really cool time with a bunch of merging technologies. So to start off with answering your question, I don't think so. I think at the end of the day, we'll be able to have closed loop ecosystems where Mars or the moon is existing on its own without inputs from Earth, right? And one of the benefits of that is, so like the majority of our system is actually plant-based materials. There's really nothing that is unique there besides the growth factors themselves. And those are the proteins that the cells are using to proliferate and then become muscle. Recapturing those growth factors is one of the hardest problems. And that is simply because it's incredibly difficult to grow those proteins. That's where the emerging synthetic biology industry right now is going to be an incredible advancement for humankind. I mean, we're talking about using biology to solve basically any problem that involves a material product. And that's going to be, I think, the key enabler to really get Mars and the moon to be independent, is taking synthetic biology systems and then applying them for retaking and taking that waste and then reapplying it.
I see. Yeah, essentially, you're saying that if you can teach microbes or whatever your vehicle, your biological vehicle is, organism to grow the things that you need, and we're learning much more very quickly how to teach it to grow just about anything, then they become the factories of the future.
Yes.
The
first pair of cellulose grown shoes was done about 2 weeks ago with fungus, I think, and bacteria.
Cool.
Wow. Yeah, that is incredible. Okay. Well, let's jump forward and ask what else might be possible in a few years. We're going to go speculative here. Okay. So it's fine if, this isn't like something you've necessarily checked out or vetted, but I'm curious sort of where you see this industry, both your industry and the adjacent industries of synthetic biology, going. What do you think that we're going to be able to do in, let's say, a couple of decades' time, given current trajectories?
In a couple of decades' time, I see pretty massive changes. I think so. One of the things within synthetic biology is looking more at personalized medicine, and this is kind of a side thing of the micromeat technology is helping to optimize stem cell therapies and whatnot. But within synthetic biology is trying to figure out how to provide the human body with the exact right thing it needs on a personal basis. And so companies right now are investigating how to create proteins that solve specific niche diseases. So things like albinism, where that is a specific protein in the body that's lacking, and there's companies that are working on that today. So looking out in the future, I see synthetic biology stepping into a position where you might have a disease or something like that. You'll go get a tailored protein to you meant to help you either solve the disease entirely or slow it. And that is something that's edible. It's consumable. It's something that's tailored to you, and it's natural. And you're just taking those things on a day-to-day basis like it's nothing. But I think also the key thing with synthetic biology is that you start getting away from this concept of like mining and logging and just kind of damaging the planet. We have everything we need in every corner of the planet at this point. And with biology and microbes and bacteria, we can transform everything that we have that's kind of being wasted and just being idle, and we can transform that into something that's usable again. And so you'll look a few decades out and you have frankly, I'm optimistic about a much more sustainable, path forward.
I'm so encouraged to hear that. I hate to invoke it, but I think it's actually a really appropriate positive analogy here, which is to say, most of us, probably all of us on this who are watching this, are familiar with the Star Trek replicator idea. I mean, taking a couple steps back from how it's implemented or depicted on that program, you're basically saying that you have these very small machines, engineered microorganisms, that can take the raw materials in the environment and transform them into whatever it is that we need. Right? That's kind of a version of what you're describing, I believe.
Well, that's what it sounds like to me. It looks like we might have lost Vincent here. So,
all right, we're gonna. Whoops. Let's remove him temporarily. Hopefully he'll be able to join us in a moment. Yeah, well, okay. Well, hopefully he's coming back in now. So hang on, everybody.
Excellent.
Hey there.
That is just some friendly Florida recovery efforts.
Well, it looks like you still have power in the house, so that's good.
For now.
No worries. Yes, for now. All right. Well, quickly, is there? I don't know if you heard my question about the Star Trek replicator. If you had dropped by then, but okay. So, are you essentially describing a somewhat less fancy version of that?
I think that's actually the best description for the technology as it stands. You look at taking, anything you have and transforming it into something else by using biology. And that is, as close to the replicator
Mhm.
as you can get.
Mm-hmm.
And
Yeah,
I think what's
well-
important here, from my perspective, is that what's cool is that this is stuff that is being done, right? We're not pontificating about this. This is occurring today. So you think about the rate of progress of computers, and so you look 2 decades out, and I mean, you can only imagine where we're going to be.
Yeah.
Yes.
So let's look 2 decades out for a little bit. What is your vision for the future in, on Earth and in space?
Yeah.
Well, I think, we're at this inflection point where we're going to be able to start seeing exponential benefits across the world, thanks to, kind of exponential acceleration of the growth in all industries, right? So, in the world of artificial intelligence right now, they're seeing incredible change thanks to transformers. We're seeing a quantum leap in space capabilities within the next decade. We're seeing synthetic biology coming out of the lab and entering real use. We're kind of taking all of these ancient industries, ancient meaning from 100 years ago, and we're rapidly transforming them. And there is actually like good signs of real progress from the legislation that's starting to push for these things to become a major player and effort. So, when you look 2 decades out, I think, visions of millions of people living and working in space, you see that definitely as a possibility. Maybe not a million, but you start to see that 1,000 mark starting to be like, that's definitely been hit. And the question is, are we at 5 zeros? Are we at 6 zeros? Where are we on that line? And it's just a wonderful merger that's happening at the same time.
Yeah, who would have known how important synthetic biology would be to sort of maturing this part of the space industry, at least the human. I mean, if we only send robots into space, well, we probably would still use it, right, for manufacturing various kinds of materials. But
yeah, they might not need lion meat, but
yeah,
like there's still uses for sure.
If it's in the bioreactor, it's all kind of the same stuff. So yeah, it doesn't matter.
Do you see any possibility of using this in a mechanical way, right? Like these muscles move organisms around. We've talked a lot about growing, this meat in order to, consume, right, for nutrients. But is this technology, possible to use for robotics, even to use that muscle tissue to articulate joints? In that way, or
in 20 years, I won't say no to that. I think the cooler application, though, that we can definitely promise is applications like industrial materials. You'll definitely see those all transition over. This is kind of an interesting fact about like the paint and lubricant, candle, soap, wax, rubber industries. They all use in some form, like biofuels especially, they use animal fats. And all of those components can be switched over. But I do, though, see this kind of technology maybe not being used in robots, but I think that you will start to see, as this tissue engineering scope evolves and grows, you will start to see more application with human, bodies and human implants.
So potentially growing organs or, grafts or, things like that.
Yeah, and especially like highly detailed. There's been some amazing work in skin regeneration where patients' own cells are seeded onto a scaffold and then put onto that area, and their own body regenerates, so deeply regenerates that even your hair follicles are able to come back.
Wow. Yeah, no, I can see the overlaps here, which is obviously going to make this a very valuable and well-funded technology as well, and that really doesn't seem to have much limits. I was just going to mention, it was interesting that you were giving some examples of lubricants, and I don't know if you said candles, some things that were all based on animal fats, but I was thinking, well, a lot of those are also made often from petroleum, which is another thing that we're trying to get off of, right?
And another thing that you
petroleum
can't find on Mars.
and you don't have a whole lot of it on Mars, probably zero. But either way, it's another way to sort of separate or sort of break the dependency on these finite resources that we have on our planet and make us kind of independent of this much larger Earth ecosystem that we're utterly, chained to right now.
So Jeff, are you saying that we're going to move into the future by lubricating our steam-powered spaceships with whale oil? I really hope someone does that. But yeah, I can imagine cultivated whale oil used on. We've talked about this, I think, on the show before. Steam-powered spaceships. So when people look to mining asteroids and bringing water back, one way to power that return trip is to just boil off the water and use steam. And so we could very much have a steampunk spaceship here in the future. I'm hoping for, at least,
with the latest technology. I love that. All right. Well, Vincent, sorry, did you have a comment about that?
No, I think the petroleum industry, especially biofuels, I think that's such an interesting application for this is actually providing a incredibly pure whale oil for their use.
Yeah, for sure. So we had another question from a listener. They wanted to know what your opinion is on 3D printed organs. So I think your technology is at least adjacent here. Is that something that you think is going to become in the forefront, or do you think that this sort of complete growth rather than kind of 3D printed is what direction we'll move in?
I think it depends on the application. I think 3D printed, and I'm also going to put a modifier on here that
that's fair.
This is a much better question for my co-founder, for Dr. Anscovy. But I think the 3D printed comes into play when you're looking at specific tailored organs for an individual. So where I really see that being important is when you start looking at doing like 3D printed valves, 3D printed kidneys and organs. And more so where I think that kind of goes is you create a base that is a 3D printed kind of like structure where the entire organ can start to grow. And then you transfer over into trying to take, a scaffolding like MicroMeat and providing it with the ability then to actually have your body create out the rest of the structure. So, 3D printed core and a entirety of the rest of the vessel.
Gotcha. Yeah, and then I have to ask the question, is that kind of organ growth, printing a scaffolding and then incorporating someone's cells, is that something which is better done in a microgravity environment than on the surface of the planet?
Yes. And I think what's really interesting with this is that when you're looking at pharmaceutical growth and protein structure growth, it's really interesting that these, at the scale that they're at, fluctuations in the microfluidic environment can spell for drastically different outcomes. So if you're looking for a repeatable, perfect process in space is great. I mean, there's no chance of that gravity field coming in to try to induce that problematic fluidic event. You can have perfect crystallization and perfect nominal cell growth. I think the challenge comes into this open-ended question in the industry of how much does gravity play a role, which is where the Pioneer Station is such an amazing application to be able to solve that.
Right, because we have, just to repeat for our listeners, probably everyone knows this, but we will have the ability to spin or not spin, and therefore provide both microgravity and partial gravity at whatever level, is required. So we're really excited to learn when that will be applicable and when it's not needed as well. Yeah.
So, Vincent, what haven't we asked you that we should have?
When the power will be back on in Florida.
Yeah. Good
I don't
luck.
answer that one either.
Yeah.
I think we've
Fair
covered
enough.
a lot.
Oh, good.
Yeah. Good. I'm glad. Yeah. Well, I am really glad that you were able to join us and talk about the incredible work that your company is doing, as well as some of the stuff you're not directly pursuing, but that is going to be an important adjacent activity, over the next few decades. I mean, gosh, I don't think I've gotten as excited about a positive future based on one enabling technology as this in a long time. So, thank you.
Yeah, we're in for a very exciting 10 to 20 years.
Oh, for sure. Yeah. And I think in a lot of different ways. So.
Oh, yeah.
Yep.
Absolutely. Well, thank you so much for coming. We really appreciate it. For everyone who listened, thank you for listening. Thank you for joining us. If you want to be part of the conversation, reach out to us on Twitter at Our Future Space or Facebook at Our Future in Space. And you can always just shoot us an email at ourfutureinspace@orbitalassembly.com. Please go ahead and subscribe to the podcast or the YouTube, depending on how you're consuming this, to make sure that you get updates when we have a new episode, and to join us during the live recordings on YouTube. So thank you all for listening, and Vincent, thanks for coming.
Thanks for having me.
Sorry, I just jumped. Yeah, you're welcome. Whoops, we got nobody on the screen that's who's talking. Hang on.
So there we go. So thank you for coming.
Yes, thank you for coming. And lastly, I wanted to say that if you're excited about the work that Orbital Assembly is doing and would like to learn about ways that you can get more involved, feel free to shoot us an email at info@orbitalassembly.com. Thanks, everyone, for listening. Till next time. Bye-bye.
This program represents the personal opinions of the hosts and their guests. The content, opinions, and views do not necessarily represent the views and opinions of Orbital Assembly Corporation, nor the organizations with which any of the program participants may be affiliated. The mere appearance or promotion of this program does not constitute an endorsement by Orbital Assembly Corporation or its affiliates. Our Future in Space. Copyright 2022 Orbital Assembly Corporation. Hosts Dr. Jeff Greenblatt and Eric Ward. Audio and video production by Tim Alatorre. Musical theme, The Last Day by Dark Blue Studio.